Hi my friends, today we model this part with the name handwheel with spheres, which seems to be simple but is very tricky. The source is from Timoteo Carrera Soto. This is the assembly and this is our problem. As you can see, here seems to be tangent this arc with the spheres. Well, in order to respect all these dimensions, we'll see that we cannot apply tangency here. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182. This is my drawing with all the necessary dimensions, and you will see that this arc cannot be tangent to this sphere. Let's start. Standard millimeters IPT, XY plane, circle, diameter of 12, dimensions from the circle to the center point. On vertical is 6, horizontal is half of 52. 52 divided by 2. These dimensions are here. Diameter of 12 and dimensions of 6 and 52. I draw a line intentionally not centered on the center of the circle because I have to place it right here and make it as a center line. Trim, finish sketch, revolve. We have the first volume, then we apply circular pattern for this feature about y-axis in 6 instances. Now we create a new sketch in the plane XY, which will be this contour, you see, and a circle. Dimensions are 6, radius 6, 1 here, and radius 2 and 3. You must observe that from this endpoint to this endpoint we draw a vertical. Let's do this. A circle in the air of 12 and a line and a vertical radius, all as a construction. Then I make this special drawing because I'll use twice. You will see. Line, up, I keep press the left button, I go here, then down, again I keep pressed the button. Oh, here is the line. I don't want to be here. Once again, a line which is an arc going to here, down, and now I keep pressed the left button and I go to the left. You see a perpendicular mark, yes? I go here, I make tangent these two, and I apply perpendicular also between this arc and this vertical. Yes? Dimensions are 2 here, 6 is this arc, 10 is from this point to this point, no, this is 10 plus 1. Then I move up this construction because I want to place here 1. This is 1. And the dimension, the real dimension here is 10 from this point, not 12 but 10. This distance is 3. And now we have 3 dimensions needed. One is this tangency between the circle and our arc, and the other are distances from the center point. Since we make this construction, it is independent. It goes anywhere without deformations or other problems. Yes? We'll use this sketch twice. Finish sketch, and now I use that sketch. Once again, I use the XY plane. I copy this sketch, copy, and I place it here. Paste. Then I hide the original sketch. I apply F7 and I project geometry to have this center. Then I make coincident this center of the circle, not this, but this. This point is the center of the circle. This is the radius. To be coincident with this point. Now we have an interesting distance here. This small vertical is interesting for us. Finish sketch, plane, new plane based on this one. This one up 1 millimeter. You see, we have here a distance of 1 millimeter, and the circle is based on this base. Now I want to go up because we have to use that section. Sketch. Now I hide the plane. Visibility. Where is the visibility? Here is. You see, inside this is the sketch. To see inside and to have no problems, I project the two spheres, these two, and then, my friends, I go here and I apply non-visible, and I have here all I need. But I don't see circles because they are yellow, so that I apply Alt Fi in succession to select high contrast to the color. Now we see better what is here. Yes? We project in this plane, we project that tiny line, and we have this projection. Then we draw a circle with the same center like this green one to here. Another circle we place here. They are equal. This circle is equal with this circle. Now we can create that arc with radius 15, which is here. You see, radius 15. We draw an arc based on this circle and this circle with a radius of 15 and tangent to both ends. Tangent here, tangent here. When you see magenta, this means fully constrained for an entity or per global situation. Okay. Finished sketch. Not finished sketch because I want to create a vertical here. So I go to this and I create a new plane in 3 points. 1, 2, 3. I intend to place in this plane the former sketch, and I intend to cover this arc, but I don't know the angle. This is why I reuse this sketch, double click, I draw a line from this center to this center and to this center, because the angle is the same for the arc or from the centers. What is this angle? Very important and very interesting. This is the value as driven dimension, we go to the parameters and we give a name to this, A and G, angle, with major letters. Okay, finish sketch. This plane, I create a new sketch in this plane. The first thing I do is to project this point because I want to draw a vertical axis with a not important dimension. I write here 12, for instance, because it's similar with many dimensions here. This is a center line. Okay, I hide all other sketches, visibility and visibility, because I have what I need. I place here this interesting sketch, you know which one. This one. You see? I copy and I place here, paste. Yes? This point is not important and dimensions are important. I visible this because I project this center. This point is the center. I project it in this very plane. I have the point. I hide the sketch and I place my new sketch, which needs 2 dimensions. I place its center to this point. Now it's fully constrained. Finish sketch. I make not visible 4 dimensions, and now we have something interesting. To be more educational, I make visible this. You notice that this solid is hidden. We create a new solid now. Revolve, new solid. Select profiles. This is the profile. Select axis. This is the only axis in the drawing, this drawing. And I apply here an angle with the name A and G, but not this direction, the other direction. Okay, you see, this is a new volume. I hide the sketch because now we don't need it, and I make visible this. No, I don't make visible. I apply now a circular pattern of this new object about the y-axis. I missed the axis. The axis is y. not X. Okay. Okay. You see connection between that instances, and now I make visible the other volume. If you want to see better what is here, I change the color, the property for the last production, and we must combine this all into only one object. Combine, the base is this solid one, and the tool bodies, this is a base body, and the tool bodies are all this, which is only one. Okay. You see? We have the border of our part. We have to create this flat feature, this one, and to do this we reuse this plane, which is 1 millimeter up from the XY plane. You know this. Sketch. I turn so, and I apply F7 to see inside. Then, even if you see here two arcs, they are because of the tangency, my friends. I was curious what is here, but this is because of the tangency. If I place it far from this view, we see one line. Now we see two lines. Our interesting line is this one. I project this, but let me make a perpendicular visibility. This is one. Control Z. You see we have here two. I make this, and I project also this. Why? Because I draw a line between these 2 points, as you can see. Then I make this construction. This short line and this arc are to be multiplied in a circular pattern. I select one. You see, I cannot select this because it's projected. You cannot multiply projected entities. This is why I draw an arc from this point to this point and equal to this. Now I can multiply these two entities. 1, 2. What is the axis? The axis is the center. How many? 6. Okay. Finish sketch. Now we have a full closed contour, so we can apply extrude. Extrude on 4 millimeters. Why 4 millimeters? Because this is 6 and we start from here and this distance is 6 minus 1 minus 1. If you want, I write here 6 minus 1 minus 1. I go back to the part. Okay, you see, we have here only one line. Very nice, very interesting. Now I apply Alt Fi in succession to go back to the normal background. All we have to create now is this boss. Yes, with a square cut. Dimensions are here. This diameter is 16, the other is 26, and the square is 9. 1 millimeter here, 1 millimeter there, 6 millimeters, all the new revolution feature. I use the same plane X, Y, F7 to create here a center line from this point to up at 6 millimeters. Then no center line for that 6 and the other 26, and close. We place this line on the center point of this to not use dimension, because our dimensions are 16 here and 26 here. Now we have a fully constrained sketch. Finish, revolve. I don't know what happens with the... no problem. Revolve, not an angle but all the circle, or not a new solid. This is what I was interested to know. We join to the part. We don't create another new object. The only solid is this one. Okay. I select this face for the last sketch. The last sketch is on this vertical, must be. I use polygon with this center with 4 sides. Place, as you can see. Then I want to place perpendicular on this. What is the plane? This is the plane. Yes, I make this vertical on this. Good. The side is 9. Finish sketch. Extrude this face through on full dimension cut feature. Okay, this is our object. Now I apply the material. Firstly, still cast. I hide edges, and I have this nice object. What is the volume? The volume is here. Update, copy, close, drawing, double click, paste. Oh, there is a difference. Very important difference, you see. We eliminate the old value and we keep the new one, even if the difference is at the third decimal. Okay, you see that our object does not have tangent here because there is that small distance of that vertical line which has no leftmost position but the one with tangency. You know what I say, yes? That's all for today. Very interesting part, even if we didn't expect it to this. Thanks for watching. Bye.